Okay, one more we're going to do here. This is your equation. Notice now that we have three spaces, three blanks now for the zeros because there's three zeros that are given there. So you're going to go through each one. Now because there's decimals in here, I'm going to do the problem actually with decimals. So for each of these, the first one, that's part separate. The x-intercept there would be 0. If you set that equal, this first part equal to 0, you get 0. The second one, if you set it equal, you're going to get positive 1.5. When you set that one equal, you're going to get negative 1.5. So those are the zeros. Multiplicities would be the powers that are on each of the factored pieces. Okay, the power on the first one would be a 3. Power on the second one is a 2, and also the other one is a power of 2. The y-intercept, if I put 0 in for all the x's, that's going to zero the whole thing out. So this is going to be 0, so we know it goes through 0, 0. Degree is always the sum of the multiplicities. We add those together, gives us 7. The maximum number of turning points is going to be one less than that. It's going to be 6. Does the graph have exactly 6 turning points? No, it doesn't say that. This means that the most turning points it could have is going to be 6. Now we're going to do the behaviors. We have to do a behavior at each of the individual zeros. First we'll do a behavior at 0. We put 0 into, not the first one because it'll zero everything out, you put 0 into these two x's. So you're going to get x cubed, 0 minus 1.5 squared, and 0 plus 1.5 squared. So you put again zeros in for not the first x, but we're putting it in for the second two. Okay, and when you multiply these together, 2.25 for this one, 2.25 for that one after you square it. And so what you'll end up getting as a result is you're going to get 5.0625, and that's going to be x cubed. Okay, so that's going to be the behavior right here. So we have 5.0625 x cubed. So we need to know, what is that going to look like? That's a positive cube graph. That means it's going to actually resemble, I'll make it a little bit more exaggerated here for you. It's going to look like this. So we have a bend in the graph right there. That will be what it looks like when it crosses through at 0. So now we're going to do the next behavior. We're going to do the behavior at 1.5. Okay, so we'll do that next at 1.5. Okay, we put 1.5 into this first x, 1.5 in for the second x. So what it'll look like is 1.5 cubed. I'm not going to put anything into the second one, so I leave that alone. Then the last one I get 1.5 plus 1.5 squared. And so now I want to simplify this. This here is going to be 1.5 plus 1.5, that's 3. 3 squared will give you 9. And then you have 9 times 1.5 cubed. So if you do that one, you're going to get 30.375. And that's going to be x minus 1.5 squared. So that's going to be what this one looks like. So 30.375 x minus 1.5 squared. And that one right there is going to be a U shape. Okay, so this is a U right here. So again, the way what that one looks like right here, I'll draw it in. It's a U because you've got a square on that one. Now let's look at the last one. We're going to do the behavior at negative 1.5. Okay, negative 1.5 will go into the first two, but it will not go into the last one because otherwise the whole thing zeroes out. You're going to get 1.5 cubed, and then 1.5, or negative 1.5 will go into here, so do a negative on this. Don't forget the parentheses around that. You don't want to do what I just did. You don't want to mess up with the negative. You're going to do negative 1.5 minus 1.5 squared, and then you have x plus 1.5 squared there. So this is what you're going to, this is, if you can see that here, you have this whole thing, and you're going to simplify that one. So if you simplify that, you're going to get the same number actually as before, but now you get negative 30.375, and that's going to be x plus 1.5 squared. Okay, so it's the same one as before, only now we have a negative here. Okay, so we put that in here, negative 30.375 x plus 1.5 squared. That's going to be the behavior for that one. So you have a negative now, you have a negative here, and you have a square. That's going to give you an upside down parabola at that one. So again, I have a negative means that you're flipping it this direction over the horizontal axis. So instead of going up, it's going to go down. It's going to look like this. I'm ready now to make my sketch. I'm going to put my sketches on each one. At 0, it's supposed to look like this. It's going to look like a positive cube. At 1.5, it's going to look like this, a parabola opening up. At negative 1.5, it's a parabola opening down. We want to look at your end behavior. Now, end behavior, you look at the degree. In this case, your degree is going to be odd because it's 7. Degree is odd, and also you look at the numbers in front of each of the x's. In front of all the x's in this case, your x value, the numbers in front, the coefficients are all positive. So that means that your a of n would be greater than 0. So if you have your degree is odd and your a of n is greater than 0, it goes down and it goes up. So it's going to go down this way and up this way. That's what your end behavior is going to give you. So here would be the completed graph. It comes up here, comes down. Again, we don't know how high it goes unless we plug points in, but this is what your general sketch is going to look like. We have 1, 2, 3, 4, we have 5 different turning points. Again, the max we can have is going to be 6. So you're not going to get always exactly the same turning points. That just means that the most you could have is going to be equal to 6. So this right here would be your completed graph. And notice again with behaviors, I mentioned before that if you have an odd multiplicity, the graph is going to pass or cross through the x-axis. So you notice it's crossing through at 0. The other ones, even multiplicities, that means that it's going to touch only but not cross at these. So it's touching right here and right here, but it's not passing through.